this out.
Yes, madam. I think I lost the video before you ended with the B inverse, so I didn't get all. Can you please go over the B inverse?
Okay, so to find the inverse of any matrix at all, first of all, it needs to be a square matrix, which is the number of rows must be equal to the number of columns. Please, whilst I'm talking, the rest you can try your hands on finding the D inverse. So we first of all need to find the determinant of the matrix, and then we find the adjoint of the matrix. And we're looking at the inverse of the least square matrix, which is a 2 by 2 matrix. Okay, so given any 2 by 2 matrix A, which is A, B, C, D, then the inverse of A is not just 2 by 2, but for any matrix at all, is given by 1 over the determinant times the adjoint of the matrix. Okay, to find the determinant of a 2 by 2 matrix, we multiply components on the leading diagonal, which is AD, minus product of members on the other diagonal, BC. And the adjoint of A for 2 by 2 is by swapping positions of members on the leading diagonal. So instead of AD, we have DA. And instead of negate the other component. So instead of B, we'll have minus B. Instead of C, we'll have minus C. Okay, so for example, if I have matrix F being 3 minus 2 minus 4, maybe 6, yes. If I want to find the inverse of this matrix, I'll first of all find the determinant, because if the determinant is 0, then it means that the inverse will not exist, and F will be known as singular matrix or non-invertible. But if the determinant is a non-zero number, then it means that the inverse will exist. So I find the determinant of F, which is given by the absolute value of F, minus 2, minus 4, and 6. Okay, so this is equal to multiply components on the leading diagonal, 3 times 6, minus product of members on the other diagonal. That is minus 2 times minus 4. And if we simplify this, 3 times 6, that is 18, minus negative 2 times negative 4, that is positive 8. So the determinant of matrix F is equal to 10. This is a non-zero number. Therefore, F inverse exists. And F is known as non-singular or invertible. So if it exists, we find the adjoint of matrix F. And the adjoint for 2 by 2, we said we swap the positions of members on the leading diagonal. And so instead of 3, 6, in the adjoint form, we're going to have 6, 3. Then we negate the other component. Right, so we negate this and then negate that. But this is already negative. So negative on negative now becomes positive. So instead of negative 2, we'll have positive 2. Then on the 4, we apply negative on it again. So negative, negative, that will give us positive. So we have positive 4 here. Now we know the determinant to be 10. We know the adjoint. So the inverse of matrix F is 1 over 10 times the adjoint, which is now 6, 2, 4, 3. Now this is scalar multiplication, okay? So we multiply the scalar by each and every component of the adjoint, and that will give us 6 times this, 6 over 10, 2 over 10, 4 over 10, and 3 over 10. You can leave your answer in this form, or you can simplify further, but do not leave your answer in decimal forms. Okay, so here will be 3 over 5, 1 over 5, 2 over 5, and still 3 over 10. Please do not leave your answer in decimal form, because If you have something like 1/3, you might be tempted to write 0.333, and then you cut off the rest, or you might be tempted to write 0.3. What you have done here is that you've gotten rid of some components or some numbers. So if you are going to use this in further calculations, instead of getting maybe 100, you're going to get maybe 99 or 98 or 95 or a different number, which will result in you making the wrong decision at the end of the day. Or even if you are manipulating pixel matrix, okay, we talked about, did we talk about some of the application yet? No, we didn't. We'll do that later on. So you realize that you do not leave your answers in decimal form. If you don't know that 6/10 will give us 3/5, okay, and you punch it in your calculator, it might give you the decimal form. If you can't do it that way or simplify it on your own, leave your answer in this form. If that is supposed to be your final answer, leave it in this form. That is fine. So what is the inverse of matrix D?
-2.
-2?
Yes, madam.
Hey.
No.
That number is
It's 3.
I said what is the inverse? I didn't say what is the determinant.
Okay.
1/10.
1/10.
No, madam is wrong.
Now why they no? Why they no?
Hello.
Madam is -1, 2.
It's -1, 2. Yeah.
3/2, 5/-2.
Hey.
-1, 2.
-1, 2.
On the row, -1, 2. Then the down row is 3/2, 5/-2.
So
5/-2. No, +5/-2.
Oh, it's -5/2.
Hey.
Please,
No.
-5/2 and 5/-2 are the same.
Yes.
Yes.
Hey, but me, I
Okay,
had
madam.
1/1 -2. -2/2.
So okay, let's all go through it together and see where probably the mistake is coming from.
Okay.
So we first find the determinant of D, which is given by the absolute value of D. So we have 5, 4, 3, 2. And this is given by product of members on the leading diagonal, 5 minus product of members on the other diagonal, 4 times 3. This is equal to 10 minus 12, which is -2. So the determinant of D is
-2. That is what I said.
It's a non-zero. This is a non-zero number, so it means that the inverse exists. Okay, so we find the adjoint of D, which is to swap the positions of members on the leading diagonal. So instead of 5, 2, we have 2, 5.
2, 5. Okay.
Negate the others, -4, -3.
Ah, yo.
So we have 1/-2 multiplying 2 -4 -3 and 5. And then last step or last 2 steps. This is scalar multiplication. So we multiply this by every component in here. -½ times 2, -2/2. -½ times -4, -4/-2. So this time that will be -3/-2, and we have 5/-2. So if we simplify this, This is minus 2 over
Minus
2.
1.
Please, who is crying there? Now, negative divided by negative.
Is 2.
Very good.
It's
It's
2.
positive.
It's
All right,
positive.
so
Yeah,
negative,
it's 2.
negative
So it's
is
2.
positive, so we have 2 here. And negative or negative positive, so we have 3 over 2.
3 over
and
2.
minus 5
5 over 1.
over 2. That is D inverse. All right, now let's look at something here.
I should write.
Hello, madam.
Yes.
Okay, please, I'm asking a question that so when the question is given to find the inverse of maybe A or B, and you find the determinant to be 0, would you still continue to
You
solve it,
stop
or
there.
you
No,
still?
no. You stop there.
Okay.
Yeah, you
Okay.
stop there.
All right. Thank you, madam.
One group will find the same matrix whose determinant. So this is D inverse, and D is 5, 4, 3, 2. And if two groups say D inverse, and then the next group will find D inverse times. We have D, and now we know D inverse. I need one group to find D times D inverse, and then another group to find D inverse times.
Okay, madam, the D times D inverse. I had minus 5, 8 on the row.
Minus 5, 8.
Yeah, and then 9 over 2 and 5.
Is that correct?
Hello, madam.
Yes.
D times D inverse is 1, 0, 0, 1.
0, 1. That's you had. Okay. Any other different answer? And okay, then what about D inverse times D?
Madam, I think
Madam.
this is the same thing.
Madam,
But,
is listen,
hello, madam.
-5,
Which
9 over
side?
2, D inverse D, or
-5, 9 over 2.
9 over 2, 8, negative, no,
No, madam, it's
that's negative 5,
5,
9 over 2. It's wrong, madam. The thing that you've written is wrong.
So how should I write it?
Okay, madam, on the row is on -5 and 8.
-5 and 8.
And 9 over 2.
9 over 2.
-5.
-10 over 2. So like
Which is
-5.
-5.
-5, yes.
Any other answer?
Yeah, madam, please the D inverse. I had
Madam,
the
please,
one negative. D inverse 2. It is with -5.
Yeah,
8,
it's -5.
9
Yes,
over
it's
2.
-5.
-5.
Any other answer for D inverse times D?
Adam.
Yes.
D inverse times D.
D inverse.
0.
That one like is even wrong.
Is D inverse times D. 1 0 0 1.
0 1.
Madam, the D inverse is -1 0 0 -1.
-1 0 0
0 -1. Yeah.
Damn.
Yes.
Madam, the D inverse D. 1 0 0 -1.
1 0 0 -1.
Adam.
Yes.
D inverse. It is this thing. -5. -8.
-5,
-8. I over 2. -5.
-5.
Yeah, -5.
Okay, let's work together and see which one of these is correct. There is a theory that we are trying to prove here times D. So for D times D inverse, okay, we multiply the rows by the columns, all right? So this will be 5 goes to -1. So we'll have 5 times -1, that is -5. 4 will go to 3 over 2. Okay, so 4 times 3 over 2, that will be 12 over 2. 12 over 2 is 6. So here plus 6. Then the same row, multiplying the second column. We have 5 going to 2, that will be 10, plus 4 going to -5 over 2. So we have 4 times -5 over 2. 4 times -5 is -20 over 2. -20 over 2 is -10. So we have here -10. Now we pick the second row and multiplied by the columns of the second matrix. So 3 on the the first column, we'll have 3 going to -1, right? So we have 3 times -1, that is -3, plus 2 going on to the second component. So we have 2 times 3 over 2. That will give us 6 over 2, and that is 3. So we have 3 here. Same second row on the second column, 3 will go to 2. 3 times 2, 6, plus 2 multiplying 5, -5 over 2, right? So we have 2 times -5 over 2. This is equal to -10 over 2. and this is equal to -5. So plus -5. If we simplify this further, we'll have -5 plus 6, that is 1. 10 plus -10, that is 0. -3 plus 3, that is 0. And 6 plus -5, that is 1. This is a square matrix. It's a diagonal matrix whose diagonal entries are all ones, everywhere else is 0. Such a matrix is known as the identity matrix. And since this is a 2 by 2 matrix, we write I subscript 2, where the subscript here indicates that it's a 2 by 2 matrix. Now let's look at the other side. So D times D inverse, we are getting the identity matrix. All right, so D times D inverse, this is equal to 1, 0, 0, 1, which is the identity matrix. Now D inverse times D, we pick the first row multiplied by the columns. All right, so we have -1 going to 5, we have -5 plus 2 going on to 3, we have 6. The same second row on the second column, we have -1 going to 4, that is -4, plus 2 going, 2 going on to 2, that is 4. So we have 4 plus 4. Then we pick the second row and place it on the columns. We have 3 over 2 going on to 5. So here will be 15 over 2 plus -5 over 2 going on to 3, right? So we have -5 over 2 going on to 3, which is -15 over 2. Then the last row, we have 3 going on to 4, that is, 3 over 2 going on to 4. That will give us 12 over 2. 12 over 2 is 6, plus -5 over 2 going on to 2. So we have, let me write here, -5 over 2 going on to 2. This is -10 over 2, which is -5. If we simplify this further, we're going to get -5 plus 6, that is 1. -4 plus 4, that is 0. -15 over 2 plus -15 over 2. Same entries, but opposite in signs. We have 0. And 6 plus -5, that is 1. This is also the identity matrix, which is 2 by 2 in nature. So you realize that D times D inverse is the identity matrix, which is the same as D inverse times D. If we have two matrices A and B, if this is the same as B times A, and all being equal to the identity matrix, then we say that A and B are inverses of each other. So A is the inverse of B, and B is also the inverse of A. Okay, so those who had the other matrices, I think your plus and minuses somewhere is what got you confused. Okay, so if I have A times B is equal to I, and B is the inverse of A, then we say that B is the right inverse of A. Where the right here is coming from the fact that the B is located on the right-hand side of A. And if B times A is equal to I, okay, then we say that B is the left inverse of A. So if one same matrix B is both the right inverse and the left inverse of A, then we say that B is simply the inverse of A. That is A times B is the same as B times A, and this is equal to the identity matrix. Or simply A times B is the identity matrix, and B times A is also the identity matrix. So please, if you keep practicing, I think it will come to you. I think now I know that your problem is not with the inverse, but with more of multiplication. So more assignments on multiplication. One more on the 2 by 2, giving a matrix.
Please, madam, your time. I don't know if you can come back in.
Yeah, it's left with 10 minutes.
Okay, when the camera icon goes off, then I know that my time is gone. Last on the 2 by 2. So if we have matrix D equal to a simple one, -1, 4, 3, 2. To find the inverse of matrix A, we first of all need to find the determinant, matrix D, and then find the adjoint of D. Okay, so here the determinant of D is the determinant of -1, 4, 3, 2. And determinant of 2 by 2 matrix, we multiply components on the leading diagonal. So this is -1 times 2 minus product of members on the other diagonal, which is 3 times 4. So we have -2 minus 12, and this is -14. This is a non-zero number. Therefore, the inverse of matrix D exists. So we find the next component of the inverse, which is the adjoint of the matrix. And the adjoint of 2 by 2 is swapping positions of members on the leading diagonal, which is 2 minus 1, negating the other components, -4 and -3. Okay, so the inverse of D is 1 over the determinant, right? 1 over the determinant of D times the adjoint of D. And this is 1 over -14 times 2 minus 4 minus 3 minus 1. Scalar multiplication. So you multiply the scalar by every component of the matrix, and this is equal to -2 over 14, -4 over -14, -3 over -14, -1 over -14. If you simplify this further, this is -1 over 7, +2 over 7, 3 over 14, and 1 over 14. That is the inverse of D. Now, before it goes off, let me write that. So -1, 4, 3, 2. This is D inverse. We had D to be -1, 4, 3, 2. -1, 4, 3, 2. Check if D times D inverse will give us the I, and if D inverse times D will also give us the I. That is your check before our next log back in. If we log back in again, we're going to look at the inverse of 3 by 3. Unless you be comfortable watching the video on the inverse of 3 by 3, do we need to discuss it?
No, madam, we want to treat it.
Okay. So D times the inverse, let me write it down for you to check for us. Times the D inverse -1 over 7, 2 over 7, 3 over 14, and 1 over 14. Then also check if D inverse times D will also give us the I. Minus 1/7, 2/7, 3/14, and 1/14, multiplying D, which is -1/432. Check if these two multiplications will give us the inverse of matrix. Check if D and D inverse are inverses of each other, or if truly D inverse is the inverse of matrix D.
Hello, madam. Hello, madam.